Number 15, summation as n goes from 0 to infinity, e to the minus n cubed plus n squared plus n power. So this doesn't look familiar to me, even to me. As I got to go through the list of techniques that we can use. For example, test for divergence. This is for sure going to approach 0 as n approaches infinity. I just quickly do it in my head, so we can't do that. I definitely don't want to do this integral if it's even a positive and decreasing sequence, but I don't even want to attempt that integral. It's not alternating series. E is always positive, the exponential function, right? So I can't use that. What else do we have? The ratio test. I don't want to do that here. There's the exponential, but these are being added together, so things won't cancel out nicely, probably, unless you do lots of expansion and all that. So I kind of don't want to do that. Root test. We could actually do the root test. I actually did it here. We got to be able to algebraically manipulate this a little bit. Okay. And then, of course, we have the comparison test if we want. But let's attempt to algebraically manipulate this a little bit first. So I can factor out n from all these terms inside this power, right? So it'll be n times minus n squared plus n plus 1, okay? And then actually we write this exponential as e to the minus n squared plus n plus 1, all to the n power. We can use properties of exponents and do that, okay? Now this is something to the n power, the whole thing to the n power. So this is a good candidate for the root test now, okay? So limit as n goes to infinity, the nth root of that guy. So technically it's absolute values. I didn't write it here because the exponential function is always positive, okay? But technically it's absolute values there. All right, so this nth root and this n power, they cancel. So we want the limit as n goes to infinity of e to the minus n squared plus n plus 1. This is 0, okay? Because as n gets bigger, this minus n squared would dominate. So what's e to the negative infinity? That's 0, okay? So what does the root test say? It's the same conclusions as the ratio test. Since this is less than 1, our series converges. So this is one way we can go about this with the root test.